Dear children, now we'll discuss continuous distribution of electric charge. Continuous nature of electric charge. What do you mean by continuous nature of electric charge or continuous distribution of electric charge? You know, previously we have discussed the properties of electric charge. So there we have learned the charge is quantized. Charge is quantized means charge is discrete in nature. Charge is not continuous. That is Q is equal to NE. But here we will consider or we will discuss continuous nature. Just it is a contradicting statement. We learned charge is discrete, but here we have written continuous nature of electric charge. What do we mean by it? When we will consider the charge is continuous in nature. So, you know, the charge acquired by a body, that is either due to loss of electrons or gain of electrons. You know, the size of the electron is very small. Suppose it is a body, it consists of negative charge. Negative charge means it is excess of electrons. If you put a point at here, at that point you have a large number of electrons, because the electron size is very small as compared to the size of this point. So from macroscopic point of view, we will consider the charge is continuously distributed over a body. From microscopic point of view, when you consider the size of the electron, then the charge is discrete in nature. But from macroscopic point of view, when we will ignore the size of the electron, then we will consider the charge is continuous in nature or continuously distributed over a body. So here it is a linear charge distribution. When charge is distributed over a line or over a length. Suppose it is a line of length L. If Q charge is uniformly distributed over it, then linear charge density lambda is equal to Q by L. If the charge distribution is not uniform, if charge is not uniformly distributed over a body or over this length, then what will be the linear charge density at here? So here we have to consider a small length dl. So the density at here lambda will be, we have to see what the charge acquired by this length dl. Let it be dq. As it is small length, it will acquire small charge, small amount of charge. Let it be dq. Then linear charge density will be dq by dl. Lambda is the symbol of linear charge density. Now come to unit. You know, SI unit of electric charge is coulomb and length is meter. So unit of linear charge density will be coulomb meter inverse. Similarly, dimension for charge A1 T1 and for length, that is L. L is in the denominator, so it will be, when it goes to the numerator, it will be L minus 1. So the dimension will be A1 T1 L minus 1. It is about your linear charge distribution. Similarly, the charge can be distributed over a surface. If a charge is distributed, if charge Q is uniformly distributed over the surface of area S, then sigma means surface charge density is Q by S for uniform distribution of charge. For non-uniform distribution of charge, then we have to see what is the surface density then we have to take a small surface area ds. So what is the charge acquired by this small element ds? Let it be dq. Then surface charge density will be dq by ds. It is at this point. Surface charge density at this point. For non-uniform distribution of charge, the surface charge density varies from point to point. Similarly, the unit, SI unit, the SI unit of charge is coulomb and area is meter square, so it will be coulomb meter square inverse. Similarly, dimension for charge A1 T1 and for area it is L square. When it goes to the numerator, it is L to the power minus 2. So the dimension is A1 T1 L to the power minus 2. Similarly, volume charge distribution, here we have to take a volume. Suppose this volume is V. If a charge Q is uniformly distributed over the volume, then volume charge density, it is rho, it will be Q by V. For non-uniform distribution of charge, we have to take a small volume. Let it be dV. Suppose it occurs a charge of dQ, then volume charge density at this point is dQ by dV. So you remember, for non-uniform distribution, the density, whether that is linear charge density or surface charge density or volume charge density, that varies from point to point. So what is the unit? SI unit, as discussed before, SI will be here coulomb meter to the power minus 3, and dimension, that is A1 T1 L to the power minus 3. So at last, one thing I want to say, that you remember, always the charge is discrete in nature, it is quantized. But from macroscopy point of view, we assume the charge is continuously distributed over a body. That may be a line, or maybe a surface, or maybe a volume.